So we're going to take a look at adding and subtracting radicals. When you add and subtract radicals, it's important to remember to start by simplifying the radicals. And when you're simplifying, remembering if you're looking at a square root, trying to take out those perfect square numbers, and if it's a cubed root, looking for those perfect cubes to divide out. After you simplify, then you're just going to combine the terms that are the same. In this example, we have a bunch of square roots and they're not the same thing underneath. So the first step is to try to simplify them. So 27, I'm going to look for a perfect square that I can divide out, and 9 is one of my perfect squares. So I can divide this out as square root 9 times square root 3. And if I simplify that, that just becomes 3 square root 3. Square root of 12, well, I can take out a 4, which is a perfect square, and a 3, and if I simplify this, the square root of 4 is just 2, so now I'm adding 2 square root 3's. And 48, is there a perfect square that comes out of that? Well, I can divide out the square root of 16 times the square root of 3. Simplifying this, we get minus 4 square root 3. I'm doing minus because in my original I'm subtracting, and I'm doing plus here because I'm adding here. Now I've got 3 square root 3's plus 2 square root 3's minus 4 square root 3's. In other words, I have 5 square root 3's, and then I take away 4 of them, so I'm left with just a single square root 3. In this example, same thing. Under the square roots, we don't have the same, so I'm going to try to simplify. So I can take out a 9, so square root 9 times square root 2. Make sure that you continue to bring down this 2 though, because that's always in front. And if I simplify this, I now have 2 times 3, because the square root of 9 is 3, times square root 2. I can go one step further because 2 times 3 is 6, so I have 6 square root 2. On this side, I have the square root of 2, and because 2 is so small, there's no perfect square that I can take out of 2. So I'm just going to pull that all the way down, and I'm going to be subtracting 3 square root 2. Here we have 5 square root 12, and 12 I know I can take out square root 4 times square root 3, because 4 times 3 is 12. Remembering to bring down that 5. Now I can simplify that to 5 times 2 square root 3's. In other words, 5 times 2 is 10, so I'm adding 10 square root 3's here. So I have 6 square root 2's, and I take away 3 square root 2's, so I'm left with 3 square root 2's, because 6 minus 3 is 3. Square root 3 is different than square root 2, so I can't put them together, but I just have left 10 square root 3. So in adding this, simplifying and combining, I end up with this. You should be able to do the same things with cube roots. So remember, when you are simplifying a cubed root, and you can tell it's a cubed root because of the little index 3 here, I'm looking for perfect cubes to come out. So perfect cubes are those numbers that you get by multiplying 3 of the same number together. So 54, is there a perfect cube that will come out of 54? So I'm going to try some. So if I go 2 times 2 times 2, I get 8, and 8 doesn't divide out. If I go 3 times 3 times 3, I get 27, and 27 will divide out of 54. So this is the same thing as the cubed root of 27 times the cubed root of 2, because 2 times 27 is 54. Now the cubed root of 27, I got 27 by going 3 times 3 times 3, so the cubed root of 27 is just 3. So I have 3 cubed roots of 2. 24, is there a cubed root that will come out of that? Well, 8 is a perfect cube because of 2 times 2 times 2. So I can rewrite this as the cubed root of 8 times the cubed root of 3, because 8 times 3 is 24. In other words, 2, because the cubed root of 8 is just 2, cubed root of 3. Going over here, is there a perfect cube that will come out of 16? Well, I start by trying again. 2 times 2 times 2 is 8, and 8 is a number that will come out of 16. So I can break that down as the cubed root of 8 times the cubed root of 2, again because 8 times 2 is 16. Don't forget to bring down that big number in the front, so that's -2 times this whole thing. If I rewrite this and simplify this out, I have -2 times cubed root of 8, which was just 2, and the cubed root of 2. If I simplify this down one more time, I have 3 times the cubed root of 2 plus 2 times the cubed root of 3 minus 2 times 2, which is 4, or I can think of it as -2 times +2, which is -4 cubed root of 2. So now my simplifying is all done. I can't go lower on any of these cubed roots, but now I want to combine the things that are the same. So here I have 3 cubed root 2's and -4 cubed root 2's. So I can put those together and I'm left with just a negative cubed root of 2. And the last one there is 2 cubed root of 3. And I'm done.